In this lesson, we're going to look at polynomial division, but this time we're going to do it by synthetic division. So synthetic division is a shortcut for dividing a polynomial by a linear factor in the form of x minus c. So it's important to note that x minus c, of course, is a factor, and we're going to need to find the zero in a moment. But before we do that, let's have a point of comparison by doing our previous method, long division. So pause the video and quickly do long division for example 1, and then hit play when you're ready to check your answer. So when I do long division, I get a quotient of x squared plus 2x minus 4 with no remainder. So now let's look at how to do synthetic division, and we better get the same answer. All right, so here's what you do. You pick off your coefficients of the dividends. So 1, 4, now I need a 0 as a placeholder, just as I did in long division, because my terms must go in decreasing degree of the variable. So it goes cubic, quadratic, I need my 0x, my linear term, which is why I placed a 0 here. Now, the value that goes outside is going to be the 0. So x plus 2 is my factor. The corresponding 0, if this were a function, would be subtract 2 from each side, so it's negative 2. So I'm going to place negative 2 outside this L shape I drew. And what I'm going to do is repeat two operations, multiplication and addition over and over. My first step is bring down this 1. And now I multiply. This is my multiplier. Negative 2 times 1 is negative 2. Now I'm adding. 4 plus negative 2 is 2. I'm back to multiply. Negative 2 by 2 is negative 4. Add. I get negative 4. Back to multiply. Negative 2 by negative 4 is 8. Add, and I get 0. Notice I just put this last part here in a box, because this is my remainder. Now, compare what we have here with what we got over here. You should spot something very interesting. This is going to always be my constant term, then it goes x to the first, x to the second. If it would keep moving to the left, it would be x cubed, x to the fourth, x to the fifth, etc. So my answer is 1x squared plus 2x minus 4. Now, quick vocab word, a depressed polynomial. This right here, this polynomial I get after doing synthetic division, this little polynomial remaining is my sad little depressed polynomial. It's a fabulous math name. Let's do an additional practice problem. You could stop the video and attempt it on your own. All right, so my factor is x minus 2. My corresponding 0 would be positive 2. Switch the sign. Pick off your coefficients. 2, negative 5, 3, and 7. Does not appear that I need any zeros as placeholders. I start by bringing down my 2, and now I multiply. 2 times 2 is 4. Add would be negative 1. Multiply is negative 2. Add would be 1, and 2 times 1 is 2. Add, and I get 9. So my quotient would be, here's my constant, my linear, and then this would be quadratic. My quotient would be 2x squared minus 1x plus 1 plus a remainder of 9 over the divisor, which was x minus 2. In our second example, notice that the divisor is not in the x minus c form. It is linear, so synthetic division can be done, but to give us a point of reference, because something weird happens in this problem, let's do the long division first. So pause the video and crank out long division for this. So you can see what I got when I did long division, 5x squared plus x plus 4 with a remainder of negative 2, so written as minus 2 over the divisor of x minus 3. So I know I need to get the same answer when I do synthetic. All right, so easiest thing to do is we still need to find our 0. So the 0 of my function is 3/2. So I'm going to put this outside my synthetic division box, and I'm going to pick up my coefficients of 10, -13, 5, and -14. I don't need any zeros as placeholders. And then I bring down, and I'm going to multiply. So 3/2 times 10 is 15. I'm going to add, and I get 2. 3/2 times 2 would be 3. 5 plus 3 is 8, and 3/2 times 8 would be 12. Add, and I get -2. So let's observe what I have here. -2, -2. My remainders are the same. Awesome. But I have 10, 2, and 8. Here I have 5, 1, and 4. Do you notice that this depressed polynomial is double what it actually should be? Well, that's because when we took this 2x minus 3 and we found our 0, synthetic only works when it's in the form of x minus c. So what did we do? We divided by 2. So that means we have to divide our depressed polynomial here by 2. So we've got to take each of these and divide them by 2. So it should be 5, 1, and 4, but don't touch your remainder of -2. So my correct answer is 5x squared plus x plus 4 minus 2 over 2x minus 3. Definitely a little bit trickier because it's something you need to remember. So some people just choose to do long division if they have a polynomial that is not in the x minus c format. It's time for you to do some practice. As always, if you have questions, reach out to your facilitator.